Hey guys, Hoser here. So, not much going on in the HVAC world today for me, so I thought I'd do a Tuesday tech tip. Just a quick one because I was talking to a friend, which reminded me that in my videos, sometimes I forget to show what I'm doing during the call. So today's tech tip is how I check pressure switches. Okay, and there's multiple ways that you can do it depending on the tools you have. So we're going to start off with talking about the purpose of the pressure switch. It's a safety device, and the purpose of that is to ensure that we have enough draft to vent out our combustion gases. So you have a motor here, which is called an inducer motor. And at the very start of the sequence of operations, the inducer motor starts and it pulls in this case, a negative draft to ensure that our venting is clear, that the combustion gases can go outside. And when it does do that, it pulls a draft which closes this little guy over here, okay, the pressure switch. So, technically these should never fail. They are a safety device, and if they do not close, technically there's a reason behind it. But sometimes they do fail because inside there is just a diaphragm, and well, lately with the ones I'm seeing, they can fail. Okay. So a couple things to check. The way I check my pressure switches is I tee in to the switch with two barbed T fittings, and I hook that up to my manometer. Now on the pressure switch, there should be an indication as to what that switch is rated for. I don't know if you could see this, but on this one, it's rated at 0.09. Okay. So what that means is that when that venter motor or inducer motor starts and pulls a negative draft, if it's above 0.9, that switch will close, and it's a normally open switch, so it closes at 0.9 and above. And typically they should be okay with a plus or minus 10%. So the very first thing I do, like I said, I tee into my pressure switches. Another way is to check it through your multimeter. You could either check through ohms, so setting it to the ohms position on the meter, which is right up here, or you could check through voltage. Now a quick check that I will do, and especially when you're having intermittent pressure switches, because sometimes these pressure switches will work, but intermittently they'll open real quick, and sometimes it won't show up on the voltage side of things. But if you have it set to ohms and the continuity test, and what I mean by the continuity test is it's going to beep, okay? And I'll show you that in a second. So when that switch closes, you should read no resistance, and your meter should sound off with a constant beeping sound. Now sometimes on these switches they'll open real quick, and you'll hear that on the beep test, which will kind of sound like a beep, 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 beep. Okay, so let's start off. I'm going to remove the wiring from the switch, just like that. And I'm going to attach my alligator clips on there. Like so. Like so. Now on this meter, the Redfish IDVM 550, I just got to switch it to the function. Okay. Now this is an app called the TECHLINK Pro, and TECHLINK. It's made by Supco. It goes with the meter, and we can visually see what's happening through through the app. So I'm just going to switch it to a bar graph. And we're going to start the unit, and we're going to listen for the beep. That's going to indicate that the switch is closing. At the same time, pay attention to your draft. Once you see this go to 0.9 and above, that switch should close. So we're about to fire up the unit. Inducer should start, switch should close, draft should show draft, and this meter should beep off. Alright, so you see our draft currently is 1.85. So we know the inducer motor is able to pull enough draft to close the switch. You can see up above we have 0 resistance, and I don't know if you could hear it, but there is a beep. My meter is sounding off. And you can also look on the app, it's showing 0.0. Okay, so that's indicating that the pressure switch is closing. It's good, and we're showing no resistance. Alright, so here's the second way I test it. I test it on the voltage setting on the meter. As you can see, it's set the volts up top. It's indicating volts on the TECHLINK app, and then we still have our manometer. Now I tend to do volts while it's running, especially on an intermittent issue, and I hook it up to my TECHLINK app, or you could simply just watch your meter. But it can be tricky sometimes. The good thing about this app is that if there is a quick flutter of the pressure switch, it'll indicate it on the application. Okay, so on a closed switch we should read 0. On an open switch we should read around 24 to 27 volts, because on an open switch there is a potential difference, whereas on a closed switch the flow of electrons is going straight through it. So the potential difference is 0, so your meter would pick up 0. And sometimes that can confuse newer techs. But I'm going to fire this up, and I'm going to show you at the start, when that inducer motor starts and that switch is not closed yet, we're going to show 24 volts here, and as soon as that switch closes, it should drop down to 0. Okay? There's our voltage. You can see that on the graph. Switch closed, 0 volts. Our draft is 1.85, which is double what it needs to be. And the unit is firing up. And that's how we test a pressure switch. If you do decide to get a fancy meter like the Redfish, sometimes seeing odd issues, fluttering will show up on this graph. As you can see, it's showing 0 volts, and at the start it was high up on the bar graph, on the line graph. So let's say this switch is going bad, then what we're going to see over the time that it's running is that graph start to flutter. So to go back, draft is good. First thing we check, okay, do we have enough draft to pull the switch in? Then we check, a quick test would be ohms. See if you have continuity on the switch. If you do, and it's an intermittent issue, tap in through your voltage side and just keep an eye on it. So a couple things to check if your switch isn't closing. Okay, sometimes these ports get blocked. There's a good, you want to peek in there, make sure it's clear. Some guys use a little piece of copper wire. Sometimes your pressure switch ports, okay, you have 2 pressure switch ports right in here, and I don't know if I could show you. Sometimes they get debris in there, okay, and these little orifices, sometimes you can pull those out and they'll slide out, and you could check and make sure they're clear. You want to go outside. You want to make sure that your venting has no obstructions, no ice, nothing in there, preventing this venter motor from being able to vent out. Common in Canada and other areas is during a heavy snowfall, for example. The ice gets in there, snow gets in there, and then you don't have a draft. Okay. Same thing with your intake. Sometimes that gets plugged and will prevent the furnace from starting. Okay, there's a clear indication if you remove the burner cover, it fires up, but then if you put the burner cover back on, it snuffs itself out. Well, then you know your intake's blocked. Sometimes your drains, okay, your trap is plugged with water. Common on a Carrier and Bryant furnace, they have a PVC trap. Very important that you clean that because they do back up a lot. And if it backs up and this fills in your collector box and your drains fill up with water, it's going to prevent your inducer motor from pulling the proper draft. Okay. Sometimes you get water in the pressure switch itself. Okay, and that will prevent the diaphragm from closing. On mid-efficient furnaces, sometimes you get birds in the venting, sometimes the chimney gets blocked, so you want to check for that as well. So to go back and summarize, this is how I check a pressure switch. Tee in with a manometer, ensure your draft, and then either check the switch through ohms or voltage. So that's today's tech tip on Tuesday. Thanks for watching. Leave a comment down below of things that you guys might do differently. If you're happy with the videos, hit subscribe and hit the bell notification to let you know when I go on. Other than that, guys, this is Hoser. See you on the next one.
Like a bird on a tree, I'm just sitting here